So yeah, that is basically St. Lucia. On top, I'm a little bit lower because there's only a very small spot at the top and everyone's there, which you can expect. So yeah, and here the hills behind me from Mount St. Cristobal, and then the financial district or whatever behind as well. Yeah, and we're gonna head that way now. Back to the apartment. I gotta do some errands, printing out some things so that I can get a car rental in a couple of days. Exciting stuff, I know. That's the tough part of traveling, but yeah. So let's go. Hey everybody! This is Larry. This is day 16 of the Leetcode Day Challenge. Hit the like button, subscribe button, join me in Discord. Let me know what you think about today's problem. Also, I forgot to do the weekly premium, so clearly I'm still in Santiago. Hope you enjoyed the intro. I mean, it's a little bit of a weak intro. Today's a bit of a rest day. Oh, excuse me. Okay. Excuse me. But I think I said that yesterday because I kind of changed up the plans, and then today I don't know. I just changed the plans. So anyway, so let's get started, shall we? Yes. I mean, I was hoping to. I was debating plugging in my thing to charge. It's like 38%. So we'll see. Maybe later I'll have to change it if it's hard. I mean, it's a hard problem, so maybe I have to do it. Anyway, let's take a look at today's problem. We have 3562, maximum profit from trading stocks with discounts. Given integer n represent the number of employees in a company. Each employee is assigned an ID 1 to n. 1 is the CEO, which I don't know why that's relevant. Maybe that's just the top of the tree. Okay. 1 based array, present and future, each of length n. Present sub I represents the current price in which employee can buy stock today. Future is the expected price in which the employee can sell the stock tomorrow. So this is a matrix, right? Is it? Or how does that work? Like, does the employee can only? Oh, is it only today and tomorrow? Is that it? I guess I should keep reading and find out. The company's higher agrees represented by 2D array, so it's just a relationship. Okay. Assume it's a DAG, or even a tree, right? Actually, I guess maybe it's not that. I don't know. That'll be funny though. Additionally, you have an integer budget represents the total funds available for the investment. However, the company has a discount policy. If the employee's direct boss purchased their own stocks, then the employee can buy the stock at half the original price. Okay. Return the maximum profit that can be achieved without exceeding the given budget. This is like the realist construction of a problem ever. Like, it doesn't really, I don't know. It's like one of those things that like they just kind of they started with a problem that they wanted to do, and then like some sort of random tree problem, right? And then they're like, how can we make this more relatable? All right, let's just add stocks to it, even though it has nothing to do with stocks really, and then see what happens. Anyway, because like I don't know that adds very little except for confusion. In any case, okay, you may buy each stock at most once. What does that mean? What is you mean like each employee stock? You cannot use any profit earned from future stock price to fund additional investment and must only buy from budget. Oh, you have a budget. Okay. I actually did not see that, but okay, fine. Let's take a look at examples. I mean, I think I get the general idea, but it's still like a way, and you know, I have to kind of think about what you call it. I have to think about complexity and stuff like that. So we'll get to it in a second. But okay. So what does this mean? 1 and 2. So that means that you could buy at 1 and sell at 4, but you have a budget of 3. Okay. Okay. I think it's time to look at the constraints real quick, just so that we don't think of it unnecessarily. Well, we only have 160 employees, so immediately it tells me that some sort of n squared type thing might work. We'll see. Budget is also 160 is also interesting because then now that means that it is possible for budget to be as a dimension, right? What I mean by that is that if this is like some really big number, then you have to like kind of, I don't know. But now it could become a dimension. It could become a part of a representation as a state, right? A state representation. So yeah, like it could be n squared times budget. Maybe that's a little bit too slow, but something like those ideas can now come into play. This is also maybe interesting. But yeah, I don't know. But anyway, I mean, my first instinct and it's one of those things where maybe there's an like a hard optimization that we have to do, but I think it's generally going to be right in the sense that what we want to do. Oh, I guess like I'm just looking at my face right now. It's kind of weird because like there's a line on my face because my laptop screen is like right there, but like it's the most comfortable seat. I don't know. Yeah, maybe this is a little bit better. Anyway, yeah. So memorization, dynamic programming, put everything in a state, and then we'll see if we need to optimize. Honestly, like, and with the constraints being that small, maybe there's some like minor thing that we have to optimize, which turns out to be a big thing, but we will see. Okay, so then now we just have a f function, right? So we have index, maybe, or current node. I just call it a node for a node of a tree. And then maybe because you have to represent whether the boss put their own stock, maybe like maybe previous for previous is equal to true. For let's just add comments, right? Node is the current node, that's just fine, right? Previous is whether the direct boss purchased their stocks. Have price for the current, right? And then there's budget left, right? I think you have to kind of, ooh. Actually, that's interesting, right? Because my intuition would have been, and maybe and this is where I could have been wrong, right? My intuition is, okay, budget that is left, right? So that's what I want to do, right? But immediately, as soon as I mean, I didn't even, I was going to say immediately as soon as I wrote it, I knew it was wrong. But even before that, right? And the reason why is because you can't do it that way because then, well, it depends how you write it. But the way that I want to write it is like, let's say we already set up the edge list. Maybe we could write up, we should set it up anyway. The adjacency list is equal to, right? We have an adjacency list. We just kind of parse the hierarchy that they tell you. Which U is the direct boss, so that means that if we're going downwards, then U contains V, right? Yeah, so something like this, and then maybe I would write like for V in adjacency list of node. Then now we have to do something like we have to do something like give budget to what I want to write is something like, like some sort of idea of tick, no tick, right? But the problem is that the natural way, and don't worry, I know how to resolve it. I'm just, kind of giving you ideas, right? And yeah, right? The previous, well, it depends on whether we bought no buy, right? So tick, no tick maybe, and then maybe we just have two loops, right? It doesn't really matter. Right, of like then now one of them is no take is false, and then now budget is budget, or take would be like I mean these are skeleton code for now, right? Just to be clear, it's not meant to be whatever. I'm just kind of using it to explain what I want to do, right? Yeah, why is my battery running down so fast? Am I running anything crazy? Probably. I have a lot of things running. Yeah, but the problem with this is that the budget, like if you kind of look at a tree, let me write it. Right. Let me draw it out. Sorry, let me load this thing. My computer's a little bit slow loading new things. the thing is that you have like a node here. You have like, you know, let's just, I'm using touchpad, so it's terrible, right? So you have like 3 children, right? The problem is that if you kind of go down here with some budget parameter, well, here you have to figure out how much is left after using all of the left side or whatever, and then here, right? And then here. So you have to be a little bit more clever than that. You have to kind of store the states in a way such that, well, you could take account this, right? And this is actually where budget is less than or equal to 160 comes into play. Because then now, instead of having this very, I don't know, I want to say intuitive, but it's not even that. It's just that it's well practiced, if you will, way of writing like a depth first search, right? But instead, what we want is actually maybe like children index or something, right? So this is the current node. Children index is the current index of the children to consider, right? And then the idea here then is actually for this current index of the children, we want to figure out how much budget to give it, right? So if C index is equal to the length of adjacency list of node, that means that we're done, right? So then we return, we're trying to maximize, right? Actually, let's just write negative infinity. Oh, no, well, I think that's fine. Let's just write 0 because that means that you just ran out of things, and you know, even if you have budget left, it's fine. And then now we have to go figure out how much budget to give C index, right? And maybe this, yeah. And I think there is actually 2 functions I want to write. I mean, you could actually put this in 1 function, but actually I think it's a little bit trickier. Or like, I don't know, for me, I'm not that smart enough to do it that way. So bear with me for a second. So again, this is what we had, right? And of course, you know, memorize. I didn't write it yet because it's trivial to write, as you can see. But yeah, so then now, if, yeah, then we want to take, no take, right? If we take, let's just say best is equal to negative infinity, right? We want to say take no take, right? If we take, then now, what does that mean? That means that we want to go over the children. We go node, 0 is the first index because, well, we just finished node, so we want to look at his children, right? So take, we want this to be true, and then it's just budget minus present sub node, right? And then now this result is going to give you a future of node, right? That part is part of the thing, right? And this is, of course, if budget is greater than you go to present of node. And actually, there are more if statements, right? But I didn't do. For example, we have to write if previous, meaning that if the boss paid, then now the cost is actually this, right? But with the present of node divided by 2, I think it's 4, right? 4 operation. Yep. So that means that it's this divided by 2. Else, then it is the without the divided by 2, right? Yeah. And maybe you could write that in a cleaner way, actually, like with a cost function instead. Fine, let's do it that way. So yeah, so cost is equal to else cost is equal to and you can even clean this up, it's fine, right? So yeah, hopefully this makes sense so far, right? Because then now you want to process the children. And then now, else no take. No take is pretty straightforward as well, right? Because now you just go to the first child as well. You have force, you remember budget, and nothing else changed, and then that's good. And then now we just have to go through all the children in the adjacency list, right? One at a time. Yeah. And here we can just say, yeah, we just figure out how much budget to give to C index, right? Oh, I was wondering why it was struggling so hard to read this, but my monitor is dim because I guess my battery is low, and I didn't plug it back in. It is, by the way, in case you're wondering how much energy I'm draining, I'm at 26% now. I don't know if that's good or bad, but I might need to plug it in the circuit. But yeah, basically now you just look at how much budget, and because it's only going up to 160, you could just do a loop, right? So then you could do like a B in range from 0 to budget plus 1, so that it's inclusive. And then now what happens is that now you break it into two pieces, right? Let's just say best is equal to negative infinity. I hope this isn't timeout, because Leetcode has a thing of timing out, and that would make me really like annoyed, because this is gonna be right, but it times out for some constant reasons. But yeah, so then now this is give B to C index, budget minus B for the rest of the list, right? So then now you can just write you can say C of, oh yeah, node C index plus 1. Oh, I messed up. I mean, I didn't mess up. I just didn't. You'll see. I just didn't finish the dot. The previous still holds because we have the same boss, and then it's budget minus B plus. Well, yeah, just giving it to C index. Oh no, it's not C index. It's adjacency list of C index. Give them. That's the new node. This is the F function, right? So then the previous is gonna be, yeah, the same previous, and budget is just gonna be B, and that should be good. Definitely a tricky one though. Yeah, this is one based, right? So F of 1, false. Budget is just budget, I think. Let's give it a spin. Hopefully this is right. Nope. Unhashable type list. That's probably true. Where my oh, this is a list. I missed node. Okay. Maybe this, but I mean that doesn't. It's a little bit helpful, but it doesn't fix it unless there's some other weird reasons. What am I looking at? 14. Oh, there it is. President of node. Why? Why would it go bounds? Oh, it's because it's one indexed, right? Yeah. Also, this is wrong, by the way, right? So I guess it's a good thing we caught it anyway. Because if it's half off, the cost is, this is why it's easy to do, so then something like this, but then this is actually -1, right? This is one indexed. The future as well. Just run it, and there you go. Wrong answer. Did I misunderstood? Oh no, this is not the profit. That's why. This is such a weird one. Why do you care about the actual profit? If okay, maybe that's why. But yeah, but it's not the profit because we only count this as the sum, and that's why every one of these is yeah, like overcounting. Let's give it a quick spin. Hopefully it doesn't give a time limit situation. I mean, it should be okay, but Leetcode being Leetcode, top-down thing, sometimes it's just messed up. On Leetcode, how that last time I had a lot of time limits. This, when I see this from my past, it usually means it's Leetcode's fault, maybe. Yeah, I mean, 775 over 790, I don't really feel like I'm gonna cry that much over it. I mean, this is probably not. This is one of those things where, like, I think this is not gonna fix it, but it is a thing to do, so I'm gonna do it. Might as well. This is a classic Leetcode is dumb situation. Maybe I can. Maybe I can think about optimizing this. I mean, before we do that, let's do a complex analysis. Maybe I misunderstood it. I mean, this could be 160, but not all of those nodes have 160. So this is like almost in combination should be one per child, right? So this is like O of n, which is only 160. This is 160 as we know, but this is 160 as well. So maybe there's like a 160 cube thing times 2. So that just ends up being too slow. Can we optimize this? Well, let's take a look at this first. Can we optimize this? Probably not so much. This is only 160 times 160 times 2. And this is all constant. That should be fine. Maybe we could optimize. Can you English? Maybe we can optimize out the max function, but we have to kind of fit. Was it 15 examples or test cases? I don't think so. I think this is probably somewhere we have to optimize. Let's see. I mean, everything is cached. I mean, one thing that I would say is that maybe I could write this a little bit differently, but it just almost feels like it's not worth the effort because it's just the code being silly. The reason why there is an optimization that you could think about doing in general is that a lot of these budget things don't really change the answer, right? Like, for example, you give budget of 0 and budget of 1 and then budget of 2. Like maybe 1 and 2 are not going to be, so you're doing a lot of duplicate work. So instead of doing 160, in theory, you can do like much fewer, almost like whatchamacallit, like a subset sum type thing, right? So that you do up to 160, but a lot of them are not going to be reachable. Do I want to make that optimization? Honestly, I'm just a little bit tired. I'm like passing out just talking about it, because this is not that interesting per se, or at least not. I don't know. How do I want to do it? Is there easy? I'm trying to avoid doing it that way by thinking about it. Because I have to like re-architecture some of this stuff to like almost like because the other way to think about it is that you basically do the same thing but bottoms up. The benefit of doing bottoms up in this case is basically what I just said, right? In that you do not need to consider all the or 160 budget every time or whatever it is. You can just do the ones that are I guess relevant, almost like in the same way that the deep, if you have a thing, right? It's such a tiring day, and I'm trying to wake up early, and it's how do I want to do it? I mean, I guess that's the way to do it. But I'm trying to think of a way to do it without basically rewriting everything, which is the hard part. But maybe it is what it is. Those for you viewing at home, I hope you appreciate this. Please, as I'm plugging in my power, because please, consider hitting the like button, because I don't know, because in a parallel universe in the future, maybe I just don't do it. If people don't like it or people don't care for it, I don't know. But today I will do it. Let me know in the comments if you just heard what I said. I don't know. Not very creative today. Okay, so let's say you have this. Then now let's doing a bottoms up. How do you do a bottoms up? Well, how do I want to write bottoms up? No, because then you just return so much space stuff if you don't do it carefully. I mean, you could do bottoms up. I don't know. Uh, mm, I mean, the other thing you can do is just do whatchamacallit, like a possibility thing for each node, pre-processed this part for all the quote-unquote critical points. That's what I do. But I don't know if it's uh, 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 uh. Okay, how do I want to write this? Give me, sorry, let me, what if instead we do, instead of best for budget? Okay, how do we eliminate the budget? Well, we just return a, uh, uh, And I think the way to do it is to remove the budget and have just like an array of all the budgets and then do them all together or whatever. But I'm trying to think about how to do it. If I do something like this, what would that look like? That means what does that mean? Right. That means that we want to solve all the budgets all at once, say, right? So maybe you have B for best is equal to, I don't know, 0 times what is it, N? I guess that doesn't change. Budget's greater than cost. Take, no take, right? Okay, I guess we have to remove this budget too. And then we just kind of, actually, I guess we could default the no take to B, right? We don't need, is it 0? Actually, I don't know if it's 0 or negative infinity. We could do negative infinity, actually. But we'll just do this, right? And then now we want to say, V pi is equal to same thing, right? Except for now we want to say we're given a cost, so for I in range of budget +1 maybe. What we want to say then is that, oops, b sub I plus cost. Is it b? Okay, it's equal to the best of well itself probably, and then bb sub, is it yeah, bb sub I wait, bb sub I plus right, something like that, but only if I plus cost is less than equal to budget, I suppose. Keep it under budget. Okay, and now we just return b. What does this look like? We're trying to eliminate budget. Okay, if this goes over, then it's just 0 times n. No, 0 times budget +1. Oh, I guess this is the only place it gets declared actually. Otherwise, b is equal to same idea, right? Just go to the next one, and then now, how did I write it before? bb is equal to f of the next node, right? I mean, we're basically trying to. I'm basically trying to take this and combine it with this in a way. I don't know that the variable names make sense. Maybe it's just next best, right? And then we just return b, because in the same way as before, if I think the way to write it is actually though this looks crazier now. I think I'm not gonna lie, I have some recollection of this. Something like this, right? Except for, I mean, there's some off by 1 errors that we can fix. Something like this, not off by 1, but out of bounds rather. Right. And then now, something like that maybe. Line, what is that? 24. Oh, did I not? Oh no, this is just, this is max. I don't know why I wrote best. It's kind of late. I plus k. Why did I write I plus k? Doesn't even make any sense. I think I just ijk or something. Yeah, looks okay. That's actually useful. Let's give me a big case and see if it's faster. It should be faster because now we're saving a lot of function calls. I think is the major thing, but I don't know if it's gonna be enough. Maybe not. Did I click the button? I think I did. Then what else do we do? You gotta be kidding me. 18 seconds. You know what? It's a long day. I'm passing out, so I'm gonna take it. What did I do last time? Let's see. Yeah, I guess last time I missed that it was you don't need it in both directions because it's a real thing. It is very similar to what I did actually. Yeah, which is not helpful per se. Oh yeah, I combined the left and the right. That's fine, but you could probably cut. You could probably actually. I mean, I could. I guess this is what I could have done today, right? In that, I think you can notice that. I think we can write this as. We can also do a prefix sum e thing, right? So right. Maybe more. I mean, this way is fine, but actually, I like it the other way though. I like to write it the other way because it's a little bit. Yeah, actually, yeah, like this because it's a little bit more straightforward. But then now, as we did this, I don't even know if you need this because in theory, maybe this gets. No, I mean, I think we need this. I mean, or when you write it this way, then now we can reduce this thing to. J is you go to budget minus I or something. No, I mean yes, but maybe that's wrong because I plus J will always be equal to budget in this case. And then you're not minimizing the cost for it to propagate up. So maybe this doesn't make sense actually. So you can probably at least subtract it by I. I don't know. Yeah, I mean, let's see what else did I did. I mean, I keep on going, right? In the past, I'm not going to do that today. I've made some more optimizations. What did I do? Oh, I guess this is actually what I just did. Past Larry is still same Larry. This is literally what I just did. I mean, I didn't submit it because I don't know. And I guess I could remove this, which is actually the big one. I guess I could submit it now, but otherwise everything else looks mostly the same. Maybe there's some, I don't know, not great. Not a fan of a problem that needs optimization like this. I don't know. But yeah. I mean, I don't know. Today is so much slower. Sorry, friends. I don't think this is a good problem for me. So I got nothing. Did solve it though. Hit the like button. Hit the subscribe button. Join me in Discord. Let me know what you think about this one. It is hard. I don't think I classified like this is a ridiculous problem for an interview. Actually, I mean, no. I mean, it still is ridiculous. It's just that it made it more annoying because of all the extra layer of optimization. Probably still tough for an interview though, so I don't know. That's all I'm gonna have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. Goodbye here from San Diego, de Chile. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.